bifurcations. We did a vertical bifurcations where the one vertical bifurcation is being done for the targeted attribute, which is a label, and the other side non-targeted attribute is a futures. So we are going to the next segment. We are taking these figures, this figure which is there, and going further. Now if you try to see this one, what we have done is that since it is a machine learning, so we are using a machine learning concept over here, and we are trying to train these particular machines based on the conditions of these data sets. Now if you try to see this particular block diagram, here in this particular block diagram I have put the previous figure. Apart from that, machine learning, model, y-test, then there is a testing is being compared, and just like a comparators between this y and this is y. I can take it this one as a y dash. It is a y dash. This is a y test. This is a y dash test. You can take it. Now, what we are going to do is that let's go back to we are first taking the test part. Test part is the 1 to 25. So this is the test part. In the test part, these segments, that is 1, 2, 3, 4, the 4 attributes we are taking, that is a x, and what is this target? As I told to you in the previous case, this target is nothing but a y. So this is y, these 4 are x. So that is what I have shown. The x trained data set is being given to the machine learning, and the y, this is a future and this is a label, the y trained data set is being given to the machine learning. Now the machine learning is using algorithms to run maybe a linear regressions or a KNN algorithms. So based on that machine learning algorithms, it will try to take these two inputs, and that is nothing but this is a input, that is x, and y is an output. And because you know, I have given an example here is that this is the input, this is output, question and answer. In the same way, this is an input, this is an output. The input and output is given to the machine learning algorithms. This machine learning algorithm will take this input and try to produce a model. Now when this particular model is being created, that means the system will able to determine the output based on these number of inputs. So you can see that this number of data input of x and y, the machine could able to produce a new model. Now in the machine learning, what we do is that we are going for a testing phase. Testing phase, where is there? This is a testing phase, that is the down portions testing phase. In the testing phase, we do a little different things. What we do is that since this x is nothing but a non-targeted attribute or a test data, this data is there, and for this data, this y test is indicate that for a given this input, this is an output. That means we know all these questions and all this answer. In the same way, for this given test, we know the output. But what we does is that in the model, we give only the x input, that is a x test data as an input, and we try to produce the we try to see that what the model is going to produce. So model in the the output of the model is y dash. So as I told you earlier, this is a y dash. Y dash is the output. Now whether this input and output has any relations is there or not, because if the machine is once the machine is being trained, then the machine is being determined based on the performance. So the model that is going to see that if the model is accurate or a good or having a good design, then automatically what is going to do, for a given x input, it will definitely going to produce a y output. But I was telling that y dash test. Y dash test is that because this model will produce a different output, because we are not giving a y test as an input. So for a x test, it is going to produce a y test, y dash test. So under these conditions, the model is whether it is a good model or it is having any performance error. That if we want to know or to determine, we want to compare the y test output with the y dash test output of the model. If this y dash test is equal to y test, then it indicates that this model is 100% accurate, and its accuracy is 100%. And if there is a variation in y dash test as compared to y test, then we term that the accuracy has been affected based on the model, because the model is being determined based on this machine learning mechanisms. So when y test data is the actual data, that is what I told you, because this data is known to us before we are going to put for the test. For this text, this y test we are known, so that's why actual data is there. Whereas y test is, or a y dash test is a predicted data. So if the actual data is same as predicted data, then we say that the model is 100% accurate. Otherwise, the model is having a error. So this is how the model is being produce a training as well as testing phase. Finally, here I am putting a validations. So it is the same thing, is that the entire data set is being divided into two parts. Let me summarize. Entire data set is being taken and it is divided into two parts. Upper part is a test. Here the test part is given and a train part is put across. Normally we put the test part larger number, so here based on the figure dimension you should not go. It is think that this is if it is a upper part is a test part, lower part is a train part, or you put it upper part train part, lower part test part, no problem. Now that is the division of the data set. Then there is another division is coming based on the future and the label. So based on the future and the label, we are going to first of all make a training of the, so in this data after dividing with respect to test and train, first of all what we do is that we are making this under the training data another divisions. That means this particular part is here. So this is a training part, test part. So this training part is further divided, and between the relation between x and y is being given this. That means this x is given here, this y is given here. Based on the machine learning algorithms, it will try to train it and produce a model. And once this model is being produced, so this model is being given as a input from the test data. Which input? Only the x input, and this model is going to produce a output y. Now y dash, you can take it y dash. Now this y is already existing in this test data. Now this y is being compared with this y dash, and the accuracy is being determined the model levels. So this if the data size is very big, data is accurate, and the data does not have an error, then the model will be more perfect. So that's why we normally say the data collection is very important, and we are seeing that in the COVID-19 data sets, where a large number of people are working, scholars are working on this data set, and thereby it could able to produce a good machine learning algorithms and able to use that particular data sets to train it as well as test it to get the appropriate results. Thank you for your patience listening for the entire machine learning test and train data as well as its block diagram structures. Thank you.